All right, little let's wait for just 30 seconds for little to join. Just 30 seconds. All right, little she's in, so we can start now. I'm now going to introduce the derivation by a rule, of which it works when you have different notation. The first notation, I explain about it, the second notation, and then the third notation. So all these notations we use when we derive by using a rule. So I'll start by using this one when we are using the second rule, of which is the most common on this differentiation by a rule. So now I'm going to write what is called a polynomial function. A polynomial function of a multiplied by x to the power of n. This polynomial function, it stands for many different functions like the straight line function, the parabola function, the hyperbola function. They can all be presented in terms of polynomial function. So you just have to write your function in this form, and then from there, you will have what is called a polynomial. A polynomial function is like a function that defines any kind of different functions like the hyperbola, the parabola, and the straight line. So now from that parabola polynomial function, we want to find dy over dx, of which is the gradient. So we are derivating the function y with respect to what? To independent variable x. Is this variable x we have here? So we are differentiating with respect to x. By using a rule, here you must get me right, because I'm going to introduce another important aspect of this chapter. We are differentiating this by rule. What do you do when you differentiate by rule? You multiply the exponent with the coefficient. The coefficient in this case is a, and the exponent is n, right? So you multiply the exponent with the coefficient. So it means you're going to get a multiplied by n, and then you subtract 1. You subtract 1 on the exponent, and that will give you what is called the differentiation by a rule. Just this formula. If you know how to get this formula, you know how to differentiate by rule. Let me tell you again what we have done here. We multiply the exponent with the coefficient, of which when we multiply exponent with coefficient, we're going to get a multiplied by n. And then from there, what did we do on the exponent? We subtract by what? We subtract by 1. So we're going to get n minus 1. By doing so, you obtained what is called differentiation by a rule. Can I give you an example so that you try? Oh, let me try it first, and then we'll do other questions at a later stage. Can we do an example?
Yes.
All right. This is an example. So this example, we're going to use it in different notations. In this notation, in that notation, in that notation. So I will pick a straightforward example which we can work with. The first one is when we have y. We're first dealing with that by using the middle notation. When we have function y equal to 3x squared minus 2x plus 1. Okay, for now, let me not have 1 because I still have to explain about that 1 thing. Or maybe I can explain it here on the question. So let's say we have plus 1. So this is a function we want to differentiate. Can anyone of you tell me what kind of function is that which we are differentiating in this case?
A parabola.
It's a parabola function. We want to derive the parabola function. So the exponent for x is 2 in this case. What is the exponent for that x?
1.
It's 1. Very true. We have 1. But in this case, do you see we don't have x on the last one?
Yes.
So if we don't have x at all time, you must know that in that situation, we have multiplied by x to the power of 0. X must be there at all time. But if it's not there, that simply means x is having an exponent of 0. Because we know any number to the power 0 is what?
1.
Is 1. Yes, very true. If we're just given, it's called a constant. If we're given a constant, it means we have x to the power of 0. Then from there, let's derivate and see what we obtain. So when we derivate y, we're going to get dy over dx. We derivated the function y with respect to the independent variable that is given, of which in this case is x. Again, I told you this is a gradient. So this will be equal to what? Can we derivate the first term and see what we obtain? What is the derivation of 3x squared? If you followed what I explained here.
It's 3 times 2, x to the power of 2 minus 1.
Is 3 multiplied by 2x to the power of 2 minus 1. That is this principle, the derivation by a rule. So is 3 multiplied by 2, 2 multiplied by 3, multiplied by 2 minus 1. Same thing we must do here. 1 multiplied by 2 is going to give us 2, and then we subtract 1 on the exponent. We're going to have 1 minus 1. Again, we apply the same principle there. 0 multiplied by 1. What is it going to give us here? It's going to be 1 multiplied by 0, x to the power of 0 minus 1. Then we simplify. When we simplify, what do we get? We get dy over dx, which is equal to 6x. 2 minus 1 is 1. So you can just write 6x minus 2. 1 minus 1 is 0. Any number to the power 0 is 1. So it's 2 multiplied by 1. But here, 0 is multiplying variables. Therefore, that is going to be 0. And I'll want to explain further in this situation. So is 0 multiplied by any number. So whenever you derivate a constant, whenever you derivate a number, you're going to get a 0 at all time. You are going to get a 0 at all time when you derivate what? A constant. I'll further explain that to you so that you know what we mean. Let me emphasize this again. We multiply 3 with 2 and we obtain 3 times 2. On the exponent, we subtract 1. Same thing here. We multiply 1 and 2, we obtain 2. We subtract 1 here, you get x to the power of 1 minus 1. So we simplify. The simplification is 3 times 2, which is 6. 2 minus 1, which is 1, is the same as writing x. Here is going to be 2. 1 minus 1 is 0. X to the power of 0. X to the power of 0 is 1. So
1.
becomes 1, yes. But this one, I said it's a constant. At all time when you derivate this, is going to give you a 0. So we can then simplify further and have 6x minus 2. And this is the derivation we were looking for, of which you can derivate by using a first principle. You will get exactly the same answer. That I can promise you. If you apply the first principle on this question, you are going to get exactly the same answer that we obtained down there of 6x minus 2. But now we use different rules or different principle in dealing with this. Here we derivated by using the what? The rule. And previously we have derivated by using the what? The first principle. Are we together?
Yes.
Yes, but here we only used one notation. Is this notation at the middle? So let me show you how we use other two notations in this case. I'll start with that last notation there, because I know you now know about the first one, but let me start by explaining the last notation. So on the last notation, you will be given a question. This expression we have here is going to be given in this form. So you're going to have dx. The notation is introduced from the beginning. So you have d sub x, and then we then write the function of 3x squared minus 2x plus 1. So when you want to derivate that, let's use the square brackets. When you want to derivate that, so whenever you are simplifying, you must keep the notation. But when you reach a point when you are derivating, that's when you omit the notation. So you keep the notation when you simplify, and then when you go to the step when you are derivating, you omit the notation. So like in this case, you can see the next step is for derivation. So when we derivate, it means we are omitting. We no longer write this notation to show that we have derivated. So it means the derivation here is 3 times 2, which is 6. And then x, we subtract 1 there, we're going to get 1. Minus, here we have 1 multiplied by -2, we're going to get -2. -1, 1 minus 1 is 0. X to the 0 is 1. You're just going to have this. So just by omitting the notation, it shows that you have what? You have derivated. Are we together?
Yes.
That's how this notation works. So it works differently with these ones. On the notation we talked about here, to show that you have derivated, you introduce the notation of dy over dx. You introduce the notation to show that you have derivated. But here is a different story. In order to show that you have derivated, you omit this notation. Therefore, you have the derivated answer. So let me also introduce that other one we have in this case of f prime x. So in that case, you'll be given a function of f of x, which is equal to 3x squared minus 2x plus 1. If you want to derivate, you're going to show by a prime. This prime, it shows that you have derivated the function f. So is f prime x equal to, then the derivation of this, we have done it before that. You're going to get 6x minus 2. Now, the derivation of 1, 1 is a constant, it's any number. You can have 10, 20, 30, as long as when you are not having a variable next to that number. It means this derivation is going to be equal to what? If you understood me, the derivation of 1 is going to be equal to?
0.
It's a 0 at all times. You must remember this. So it means the final answer in that case is this one. Are we together?
Yes.
Yes.
Yeah, it's a lot of work. So now time is not on our side. I'm going to give you 3 questions which you must do and send back to me immediately after this lesson. So I'm going to send the questions to you on WhatsApp. So otherwise, for today, let's end here with regard to these questions on the board. Tomorrow, we're going to continue with the limits. Immediately after we introduce the limits, we'll then go back to do more questions on the differentiation by rule. And we also do some questions on limits. So otherwise, this is the end for our lesson, and have a good night.
Thank you. Bye.
Bye.